Here we have another worked example. You can call it a numerical, or you can say it's a story sum, and it is about the concept of the law of the conservation of the momentum. The law of the conservation of momentum says that the momentum, the total momentum of a system before the collision and after the collision remains constant. Here we have an example in which we have a bullet of mass 20 gram is fired from a gun with the muzzle velocity of 100 meter per second. Find the recoil of the gun if its mass is 5 kg. You see, the momentum before the gun is fired and momentum after the gun is fired, they both momentums will be equals to each other. Momentum before the gun is fired, because the gun is not moving, the bullet is not moving, so that momentum will be zero. But the momentum after the gun fired, that will be the capital M multiply the capital V plus small m multiply small v. Here the capital M stands for the mass of the gun and the capital V stands for the velocity of the recoil, and small m represents the mass of the bullet and the small v represents the velocity of the bullet. So the momentum after the gun is fired, that will be equal to the momentum before the gun is fired. So I will substitute these values into this equation. So the mass of the gun is 5 kg, so 5 multiply V, and plus the mass of the bullet is 20 grams, so I will divide it with 1000 to convert it into kg, and its velocity is 100. So 20 divided by 1000 into 100, and that whole thing is equals to 0. So we will have 5v plus 2 equals to 0. 5v is equals to 0 minus 2. So v will be minus 2 by 5, and the v will be equals to minus 0.4 meter per second. Here the recoil velocity has a negative sign. The negative sign means that it will be, the gun will recoil in the opposite direction to that in which the bullet is moving. If the bullet will go forward, the gun will recoil in the backward direction.